Hi guys, welcome to another electronics repair video. I received this in the post last week from GVDA. These make a range of multimeters amongst other items, and they have a store on AliExpress, and they said, would I like to receive one of their multimeters and have a look and let them know what I think of this for the use of electronics repair. Is it any good for that use? So I'll just show you their shop page, and then let's open it up and let's see what we've got in the box. So let's have a quick look. I mean, there are some reviews on here, 4.8 out of 5 stars. What do people think of these? What's the general opinion? Then we'll have a look ourselves and see what we think of it. Well, works well, convenient to use, easy fits in the pocket for the 4 key. Okay. Lots of stars, but generally not many people say much about it. People like it, but they don't say much why. So let's have a look and let's see what we think. I've not used one of these pen type multimeters before. I've seen them, but I've never actually used one. So this is a first for me. Let's have a look to see what's in the box. Oh, this is the device. 600 volts, safe enough, I would think. Does this screw off or come off? Oh, you see, it has quite a long probe, which is probably quite handy. It's not extremely sharp like the ones that I like. These probes actually interchangeable. You know, I don't know if they are. I think they just stay on there. There's a little protector on here, so we can get rid of that. And I'm guessing, first of all, we need to put some batteries in it. Yes, it looks like it needs batteries. So let's see what this actually takes. And while we're at it, is there an instruction book? Yes, there's something in here like a Christmas cracker. Okay. Yeah, we have an instruction book in English. Okay, we'll put some batteries in there. Let's take a look to see what we can do with this. The meter takes 2 AAA size batteries, so I'll put batteries in it. I also noticed that you can actually just take the end cover off this, so you've got an insulated probe, which is good for when you're measuring high voltages. I mean, the thing sits quite well in your hands. So there's like a ridge here, and it's sort of like ribbed as well where you hold it, so you can hold it quite well. You can also hold it well here. So I'd say it's designed to be fairly safe in operation, that you're keeping your fingers away from the high voltages. That seems fine to me, although I'm not an expert on safety regulations, but it certainly seems to work. Your negative lead plugs into the back end of it, and then you have a probe. Again, I think we can actually, we can take the little cover off as well if we so wish. So there we have it. We can switch on, and the first thing I noticed, and you probably noticed, is the display isn't very bright. I'm guessing this is probably to conserve battery life, and I don't think there's any brightness setting on it. I will have a look in the manual. I mean, it's perfectly visible, but it's not particularly bright. I'm not sure if you're working outdoors. Yeah, you probably have to effectively just shield your hand over it maybe to see it, which obviously means you can't hold this in place. I think probably this could be quite handy if you had a longer lead on here with a crocodile clip. Maybe you could just clip to the chassis of whatever you're working on, the ground, and then you can just probe around with this. It has a few features I've noticed. So this is the torch. So there's a little LED in the back of here. There you can see the torch is on. Actually, it's quite bright. So yeah, you can see that's quite nicely illuminated wherever you touch it. It doesn't quite illuminate where you are, but I'm sure that's good enough. Yeah, I'm sure that's good enough. And obviously that LED could have been angled slightly to do that, but I don't think it's a problem. Looking at the instruction book a little bit, you have the normal sort of ranges you would expect on this. So you have a voltage range, which you'll read down to 1 millivolt, DC and AC. There's no millivolts range. Then we've got mega ohms, we've got ohms, just mega ohms and ohms, 2 ranges. We have a diode test mode. We have a frequency mode. We have a capacitance mode, let's say nanofarads. But you can see this display isn't particularly good. I'll be honest with you, it's better to look at this as coming out on the camera. Live, so this will effectively let you just touch a conductor, and it'll tell you if it's live or not, basically. And this one, I had to look it up, this PA. So this is for 3-phase mains supplies. And reading the instruction manual, it basically allows you to detect the phases. So live detects a live wire, okay? And it'll show you if it's a weak electrical field or a strong electrical field. Maybe that's live and neutral, you know. So low and high, yeah. Phase detection. So press the function for phase. And then you can effectively measure or find out which phase is which on the electrical supply 3-phase. It tells you how to basically use it. I'm not quite sure how this works, how it knows the phase. It'd be interesting to know how that actually works. It says you need to do it in 1 minute, but it will tell you which phase is which I'm sure it is of use to electricians, although I'm not an electrician. So we have that. The probe also has this auto mode. Now this is like the meter out the Kaiwitz meter, the smart multimeter. In fact, they call this a smart multimeter. So the way the auto range works is you select auto, you connect your red probe, yeah, contact the probe to the measured subject or resistance, and the meter will automatically recognise the measured input. So if there's no voltage there and the resistance is below 50 ohms, it'll give you a buzzer, or I'm assuming it also measures the resistance, and it then goes to say that if there's a voltage there, it'll measure voltage. You know, actually it doesn't explain it very well here, but I know what it does from the other meter out at the Kaiwitz. So basically, if there's an AC or DC voltage, it measures the voltage and tells you if it's AC or DC. The Kaiwitz also gave you the frequency, which this doesn't. And if you find there's no voltage there, but there's a resistance there, it gives you the resistance. And if it's a short or anything below 50 ohms, it bleeps the bleeper. It mentions here the minimum measurable voltage in this mode is 0.8 of a volt. I haven't looked at the Kaiwitz to see if that has a minimum, but I don't seem to see it mentioning one in the manual. Capacitance measurements, set it to capacitance, diode measurements, all fairly standard things for a multimeter. We can see that, as I mentioned, it reads down to 1 millivolt, and these are your various ranges and the resolution, okay? I mean, that's fair enough for a multimeter, but this doesn't have a millivolts range, and for electronics repair, a millivolts range is really something that you need, okay? AC voltage again, down to 1 millivolt. Frequency response between 40 hertz and 1 kilohertz. It gives you a true RMS reading. I'm assuming other than that it does read the frequency, but not maybe true RMS and the amplitude. Let's have a look. And there's some ranges. The resolution of the resistance on this little meter is only 1 ohm. So it isn't really useful for measuring low resistances. That's the lowest it will read to. And then your normal range is up to 40 megaohms. That's actually quite high. Mentions the continuity. Capacitance, it will only read down to, this is 0.1 of a nanofarad. So this is effectively 100 picofarads. And it will read up to 4,000 microfarads basically, which is not an amazing range, but it's fair enough. And the frequency actually goes up to 4 megahertz. That's the maximum frequency. So apart from radio frequency circuits, and even fair enough for, you know, AM radios and such like this would actually read. Then that's about it. What you will notice, this doesn't have a current range. There's no amps or milliamps range on this, which I suspect is probably something that is true of all of these types of meters. I haven't used a pen meter before, but this doesn't measure current, which again limits its use for electronic repair. But to be quite honest, I don't think this product was really designed for electronics repair as such. I think this product is designed for electricians, auto electricians, auto mechanics, and these sort of people who want to know if a light bulb's okay, or if they have any voltage, 12 volts or whatever they're looking for. And for on-site work like that, switchgear and such like, air cons and all these things you might be working on. And I suspect for that kind of use, this is fine. It's easy to hold, especially if you put a ground clip on here. You've just got the thing in one hand and you can dab around and you can see the various readings. You've got the torch to help you, which is nice. And to be quite honest, any advanced fault finding, even if people in those fields even do, I mean, probably aircon engineers and such like, change the control board if it's faulty, and I'm sure this will tell you if it's faulty. So I think for what this is intended to do, which is not the sort of work I do, it's probably absolutely fine. It's probably a good product for that, and I think I would be unfair to misjudge this based on the type of work that I personally do. Anyway, having said that, let's just have a quick look to see how this works. Let's have a look at this thing where it says it only measures to 0.8 of a volt and auto range by using the bench power supply. And then let's just check a few of the things we want to know for fault finding, like how fast is the response when you are in continuity mode. So basically, how fast does it bleep? Oh, actually, just trying it. It's very good at that. It's very good at that, I will say. Right, let's just make a few tests with it. Here's the bench power supply. I've just connected a couple of crocodile clip leads to it to make it a little bit easier. And we'll take this off as well, so we can just attach our power supply to our meter. We're on auto range. Yes, and it took a second or so. It's got to 5.06 volts. I don't know how well this is calibrated, all this, but given the purpose of this, I believe the intended purpose, I don't think the exactly accuracy is that important for the type of work I envisage people would want to do with this. But anyway, we're on 5 volts, and let's see what happens then if we decrease the voltage down to 0.8. Well, I notice it takes a little while to respond, so when I change the voltage, oh no, I'm below 0.8 of a volt, and it's still reading the voltage. That's all the way down now, so how low can we go? And then it went into auto mode. It's now in ohms mode. Okay, so it's reading low voltages, but I mean the manual says it won't, so this is fair enough. I'm just interested. I'll put it to 0.4. Now let's just attach it on here and see if it reads it. Yeah, it doesn't, so this must be what they mean to say, that if you have a voltage less than 0.8 volts, it won't detect it in auto mode. I'm assuming it measures it in volts mode, or DC volts. Let's have a look. Yeah, it's reading it fine. So I mean, they do tell you that in the manual. That's fair enough. It's got to have some threshold, I guess, at which it decides as either a voltage or a resistance. Okay, that's fair enough. Let's have a quick look around a circuit board with this, just testing it for short circuit finding. Let's see if we can measure frequency. So we'll look at a VRM output and see if we can see the frequency on the motherboard. And then we can have our final thoughts about it. I've taken a crocodile clip lead actually and plugged it into the back of the pen. So we just clip this chassis. So now I've just got hands free. Yeah. So let's have a look. So we can just go say 3.3 volts on here. Turn it so you can see it. Yeah, I'm sure you can see it now. 3.37. It's working. 12 volts. Yeah, 12 volts. Again, I'll hold it back here. Well, this is low voltage, so it's not that important where you hold it. So the red one's 5 volts, so it's doing the job. Let's try one of the low voltage rails. I'll just go to the VRM 1.74. I'm not sure, yeah, I'm sure you can see it, 1.74. So it's measuring the voltage okay. Let's just try the frequency mode and see if I actually read the high frequencies. Okay, so I want to see if I can see the frequency of the VRM. I'll try and get the camera a little bit nearer. There you go. So let's see, this should be somewhere in the hundreds of kilohertz that this is oscillating. Oh yeah, 294. So that works fine. That tells me that the oscillator is running. I'll switch off. Now, let's just try it for a little bit of like resistance checking. Okay, so we're going to put it into continuity mode. I'm in continuity mode. That is pretty damn good. I mean, you see, I'm just touching the. Yeah. I'm sure for short finding, this is actually very good. Actually, this is surprisingly good. You know, that might even be faster than my fluke meter when it comes to that. I have to say that I am impressed with. That's impressed me with that. Just how fast this reacts when you're tracing shorts like that. Let's go into diode mode and see what it does in diode mode. Let's find some diode junctions. Does it bleep? These are transistor. No, probably a voltage regulator. Let's see if we can find some diode junctions on here. It might just be easiest just to actually get a diode. Yeah, let's just get some components. Actually, let's take a transistor. So let's see if we can find the junctions on this. Depending if it's NPN or PNP. I know the base is in the middle on these, just anyway. But let's have a look. So we've got the meter. Oh, I've changed the function. Oh, okay. I just caught the button. Bit easy to do. I'm in diode mode. No continuity mode. I'm in diode mode. Okay, let's try it now. So, okay. I thought I had a reading there. Try again on the other one. 0.677. Okay. Let's see if we can see the emitter. So the emitter would have a slightly higher reading than the base. Oh, I have noticed this. It's quite easy to catch the buttons when you move it in your hand. 0.682. 0.677. 682. It's definitely finding the emitter which has the slightly higher reading, so that's okay. So it does work as a diode tester. It's a little bit of a shame it doesn't give you a bleep. So that's something I'm somewhat unimpressed by. And now let's have a quick look at the capacitance range as well on this. Normally multimeters are quite slow at reading capacitors, and the higher the value of the capacitor, the longer it takes to read it. That's what you would normally expect to happen. So this is a 0.22 microfarad. Oh, that's pretty quick. For a multimeter, that's pretty quick actually. Yeah, 232 nanofarads, 0.22. Now let's see what happens when we try to measure a high value capacitor. So this is a 3300. Now this is where you expect it to take some time. And like just about every other multimeter I've ever used, it did take some time. But it read it okay. So it reads capacitors fine. Takes longer on the higher value ones, but as multimeters go, that is completely normal. This has a hold range, H. So we press the button and we get a little letter H here. I'll show you the display a little bit better in a moment. And does this actually hold the highest voltage it finds? No, it doesn't seem to do that. You know what, I bet what this does is, if we switch it off, hold, yeah, we probe something, and then we hit hold, so effectively if we couldn't see the display, we trap the wires in the fan, and it holds the voltage. So yeah, that seems to just be able to, you hit that if you want to hold the voltage, you can have a look, rather than reading the highest voltage it finds. So if we have it on hold, and I now go to a 12 volt supply, yeah, it still stays where it is. I just have to hit the button. Yeah, I think that's probably intended for if you want to make a reading and you can't see the meter, just probe somewhere and you hit hold. Again, that can be quite handy in on-site situations. It could be, you know, quite a useful feature. Let's just have a bit of a close-up look now. So if I just hold the button in for a moment. So you can see now the display. It's actually quite readable, although it does catch the light quite a lot. If you don't have the light shine on it, that's perfectly readable. It certainly is readable as my LCD display meters, and I'm sure in most situations on site it'll be fine. Maybe in high sunlight, if you're working on a car outdoors or something, it might be a bit of a problem, but I'm sure again you can just shield it from the light and you can take the reading. So on the front of the meter are 3 LEDs, and I'm sure you noticed in continuity mode that the green light flashes as well as the bleep, which is a very nice feature, apart from the fact that if you're actually deaf or hard of hearing, if you're working on site where it's a noisy environment, to comply with health and safety rules you would have to wear ear defenders and you wouldn't be able to hear the meter. So that gives you a very quick indication, even before the display can react. You know straight away you've got continuity. Yeah? So that I like. Now the other 2 LEDs, and looking at the manual, it doesn't particularly mention them. It says here that number 2 is a signal intensity indicator, okay? And I looked all the way through the manual and there's no other mention of signal intensity indicator. But what it does mention is about live wire detecting. So it's saying insert the red probe, yeah, and remove the black probe. So you take the black probe off the meter, so we'll do that. Okay, take that off the meter, so we've just got the red one. Use a red probe to contact the conductor. A weak electrical field signal is detected. You'll get an L and the buzzer will sound slowly and the green light is on. Okay, and when we have a strong field, it will say display H, the buzzer will sound quickly and the red light is on. Now I'm suspecting that refers to these, even though it doesn't say signal intensity indicator. So let's try it. So we've got the meter. We'll just put it into live detection mode. Live, yeah. This is a mains conductor. Now my mains in the workshop on the bench is isolated, so it's running through an isolation transformer. So therefore I don't have a live and a neutral. I just have 2 AC signals. So let's see what happens. Well, I got green, green, red, and H. Okay. And I get the same, which makes sense because my mains wiring on the bench for safety reasons is isolated. Okay, I'm certain that if I had a mains socket which effectively is grounded with 1 neutral wire, you would get the slow bleep and the L. It's just not what I have on my workbench. Okay. Ah, there. Okay, go to the earth terminal. For some reason it finds a low intensity. That's open. It's not going anywhere. It's, you know, it's not connected to anything. But I'm guessing that's just picking up some electrical field from the AC. So that definitely works. I'm happy with that. Of course, this video requires a conclusion. In my opinion, if you are working on the bench, as I am doing electronics repair, this pen meter doesn't really have all the functions you need. It's certainly fine for taking voltage measurements. We saw the frequency measurements work fine, and to be quite honest, the short circuit continuity detection is probably the fastest I've seen. It was certainly, that was impressive, but the lack of millivolts range, and particularly the lack of any current ranges, would limit you in some of the measurements that you're able to do. So for that type of work, it's not really an ideal solution. If it's the only thing you've got, sure, you can do some things with it, and I wouldn't deny that. However, if you are the sort of engineer who's basically doing site work and electricians, where you need to know if conductors are live, basic continuity testing, the 3-phase detection obviously is aimed at those type of engineers. So if that's what you're doing, or you are doing auto electrical repair, electrical equipment, you know, like electro-domestic stuff, washing machines and dishwashers, air conditioning and similar products, I'm sure this will tell you everything you need to know, and it's a very convenient form. You can put this easily in your workbench. It's an inexpensive tool, and I'm absolutely certain it'll do the job just fine. So considering the market this is aimed for, I have to say it's a good product in my opinion, even though I don't particularly do that type of work a lot. But having said that, this will go in my tool bag, and when I'm out working in pubs and bars, I'm absolutely sure this will come in useful for taking basic measurements, and then I'll decide afterwards if I need to bring something back to the workshop for more advanced repair work. I hope you enjoyed that little review, guys. It was interesting to me, first time using one of these. Of course, your comments are always valued, so get them in the comments below. And I will see you all soon on another Learn Electronics Repair video. Ciao for now, guys.